As I said earlier, collaborations are based on contracts. A contract can be explicitly defined in terms of a method signature or an interface, but a contract can also be implicitly expressed in terms of its conditions of use and its after effect guarantees. So when an object thinks about its collaborators, it has to ask itself an existential question. We've all asked ourselves, why am I here? Why do I exist? What do they want from me? Under what conditions can I guarantee my services? All right. And so, as the book says, this is the fine print of the contract. Sometimes this is expressed in terms of data types. So since C# is a strongly typed language, it would be difficult to send data to a collaborator that's of the incorrect data type. It's defined in its method signature, the types of input that it will accept. It'd be very difficult for us to do that unless there was some dynamic typing going on. In most situations, this sort of thing would be caught at compile time, right? It wouldn't even let us compile the program. In other circumstances, like in a dynamic situation, we may not know ahead of time. And so it would have to be, the fine print would have to be expressed through runtime exceptions. But is that enough? Is that all we need to do? Well, that's really a decision for the developers in each project to make. There are implicit ways of enforcing the fine print of the contract, and that one of the implicit ways you can do that is through structured exception handling in C#. So every component has to trust its collaborators to be able to do the work that it's been assigned to do, but this really comes down to how much you, the developer of the object, trust other developers of collaborating objects to have done their job, all right? And with trust comes verification. I trust you, but let's make sure you didn't do something or you didn't miss something. I wouldn't want the both of us to get in trouble, right? So we have to be able, objects have to be able to trust one another, and what we're really saying is that developers have to be able to trust one another, that we've done the necessary due diligence to make sure that our objects are producing the correct results in the fine print of the contract. So this verification is usually in the form of input validation. So we're checking to ensure that the data type is correct if dynamic types are involved. We're checking to ensure that the data is not null as it comes in through our method signature. We're checking to ensure that data falls within accepted range or boundaries and so on. And ideally, there would be some declarative way to include this fine print up front. And I suppose that it's possible, but C# really doesn't give us that mechanism just automatically. Now, you could use something like data annotations. That's what we see used in ASP.NET MVC and the Entity Framework. So we could concoct our own custom attributes, but honestly, that would require a lot of effort, and we may not even cover all the cases. Usually, it's sufficient to just use existing exception objects that are built into the .NET Framework, or create custom exceptions that are based on system.exception. So here's the scenario. The fine print is I can guarantee my work, but I have to make sure that what I accept is within these boundaries. So we do all these validation checks, and when we find that the data that's been input doesn't fall within those boundaries, whether it's data type or the actual values or whatever the case might be, then we throw an exception to the caller, right? So we rely on C#'s try-catch, and finally to safeguard collaborative messages to ensure that they're successful and that they don't violate the fine print of the contract. And then finally, I guess another way to make sure that objects abide by the fine print of the contract is through unit testing. So we can make sure that as we refactor our code over time, we haven't regressed and introduced some violation of the fine print of the contract for a particular method in our objects. So that is with regards to data that gets passed in to our objects. But what about our guarantees? Once we get valid data, how can we guarantee that what we're outputting is the correct value? Well, it's similar, I suppose you could say. Each object should provide an after effect guarantee. If you give me valid input, I guarantee the output. So how is this contractual guarantee expressed? Well, we explicitly define the after effect guarantees contractually in our method's return types, right? So we're accepting certain input types and we're returning values of a certain output type. And again, we have to ask ourselves the question though, but is that enough to guarantee that the object did what it was supposed to do, just return the right type? Well, that only guarantees the data type. That may not be enough. Here again, we have to make a decision, and it usually comes down to how much should the object trust its collaborators? Or again, more correctly said, how much do I trust the other developers who are supplying collaborating objects whose services that I'm relying on? And how much should they trust me? All right. So if you don't trust them and they don't trust you, then you probably should add a try-catch around every single call that's ever made outside of your object. At that point, you can verify incoming data and you can verify what comes out of the object, what's returned by the method call. But probably the best way to guarantee the after effects of your object is to actually build unit tests. And the more unit tests you write with sample input code and that produce the desired result, you and your team members will begin to trust the objects to do their jobs faithfully. And again, if we ever make a change, you can test the regression, make sure that we haven't fallen back and actually broken something. So that's a lot of work to write unit tests to that degree. And a lot of this depends on the goals of the team. But ideally, in order for there to be collaboration, there has to be trust. The trust that you're going to give me what I need and trust that I'm going to return back to you what you need. And the way that we establish trust is to verify our inputs and our outputs. And we can do that live at runtime, or we can do it ahead of time using unit tests. All right, we'll continue on the next video. Thanks.